Welcome back, class. So today we're going to talk about integrals of trig functions. And to start with, I have reminded you of the formulas for the derivatives of trig functions. And I want to use this sort of as a jumping off point to write down the derivative formula, the integral formulas that go with these. So for example, we could start with the integral of cosine of x dx. Okay, and note what this is asking is what's a function whose derivative is cosine of x? Well, from before, we know that sine is a function whose derivative is cosine of x. So that tells us that this integral is sine of x plus c. Now, you might notice this line and this line say literally the same piece of information. They both communicate to you the fact that the derivative of sine is cosine. They just express that idea in ways that are backwards from each other. So if you were still preparing a note card or a list of things to remember, there's no reason you need to remember both of these facts, because these two facts are, in fact, the same fact, just written differently. Okay, but while we're at it, we can also figure out, okay, hey, what's the integral of sine? Now, the derivative of cosine is in fact minus sine, so that means I can't just write cosine here. I need a minus to cancel that out, so this is actually minus cosine of x plus c. Now, please remember that both the derivative of sine and cosine are sort of the other one, except one of them's got a minus sign in it. The integrals work the same way, except it's the other one that has the minus sign in it. So please be mindful of this if you're, again, trying to remember this. It's very easy now that you have both this pair of things and this pair of things, just to flip around where the minus sign is. Just be careful. Okay. Now, you might next be expecting me to tell you about the integral of secant and the integral of tangent, but unfortunately, this list of information we already know does not tell me anything about the integral of secant or about the integral of tangent. So for now, we just don't know the integral of secant or the integral of tangent. And later, if we're lucky, we'll find out what those things are. But for now, what we actually know is we actually know the integral of secant of x tangent of x, and we know the integral of secant squared. So I'm going to record those here just for posterity's sake. And just, again, to emphasize that this is the same formula that we already have, just written backwards. Okay. And so, again, just not to put too fine a point on it, but just to say it one more time, every time someone gives you a derivative formula, they are also giving you an integral formula. All you have to do is swap around which thing is where, and then you'll have the analogous formula. Okay. So with that, I want to just do a couple examples here. So first up, let's do the integral of 2 cosine of x minus 3 sine of x plus 9. And so here, when we go to do this, we're going to follow along with our formulas up here. So this is going to become, so the 2 cosine of x is going to become a 2 sine of x. minus the 3 sine of x is going to become a 3 times minus cosine of x. Okay. And then going back to the last video, the 9 is going to become a 9x because we view, again, this 9 as a 9 times x to the 0th power so that we can use the power rule. And then we don't forget that we still get a plus c here to remind us that we could have an arbitrary constant. Okay. And this we could clean up just a tiny bit, and we could write this as being equal to 2 sine of x plus 3 cosine of x plus 9x plus c. Okay. Let's do another example here. So I want next to do the example secant of x times secant of x plus tangent of x. And I first want to note, I have a product here. There is no product rule for integrals. So if I have a product, there's no way I can do this just by knowing sort of how to do the things separately. So if I have a product, I probably want to multiply it out first if I can. So this is actually going to become the integral of, and so secant times secant is secant squared of x. And then plus, and then I've got a secant of x times tangent of x. And so now, if I remember, it wasn't that long ago, so hopefully we do, we know the integral of secant of x tangent of x, and we know the integral of secant squared. And so the integral of secant squared was tangent. And the integral of secant tangent was secant. And then we get plus a constant term there. Okay. Next up, what if I gave you something like the integral of 7 divided by 1 plus x squared dx? Now, at first you might be inclined to say, well, that doesn't actually have anything to do with trigonometry because there's no trigonometry in it, and you might try and say, oh, this is something like 7x over x plus x cubed over 3. It's not that. You absolutely cannot integrate a fraction by integrating the numerator and the denominator. And so if I actually really want to do this, I need to actually think if I somehow know some function whose derivative is something like this. And in fact, we actually do if you think back to our inverse trig derivatives. And so, just like I said before, every time someone gives you a derivative formula now, they're also giving you an antiderivative formula. And so if someone asks you to integrate 1 over the square root of 1 minus x squared, you know the answer there is arcsine. If someone asks you to integrate minus 1 over the square root of 1 minus x squared, that's arc cosine. Or minus arcsine, whichever you like better. Or if someone asks you to integrate 1 over 1 plus x squared, that's going to be arctangent. And that happens to be the one that was relevant here. Okay. And just because I didn't put it anywhere else, if someone asks you to integrate e to the x, well, the answer is e to the x. Okay, so e to the x works the same both ways because neither differentiating nor integrating changes anything. But again, because we know these formulas, and only because we know these formulas, we know that we can think of this integral of 7 over 1 plus x squared. We can think of this as the integral of 7 times 1 over 1 plus x squared dx. And so by that sheet, this is 7 times the arctangent of x plus c. So that will be our integral. Okay. Look out for those. The ones that have the 1 over 1 plus x squared and the 1 over square root of 1 minus x squared. Those will show up on the homework, and it's easy to miss that they're just the derivatives of our inverse trig functions. So I promise those will show up, and they'll probably be among the most asked questions on the web work, because, again, it's easy to miss this and try and do something way more complicated than you actually have to do. Okay. Last up, let's do the integral of 3e to the x minus 4x to the e dx. Okay, so here I know because the derivative of e to the x is e to the x, the integral of e to the x is e to the x. So this is 3 times e to the x minus 4 times. Yeah, but then I have to think, how am I going to do the integral of x to the e? But x to the e is just a power, so this I can use the power rule for, which means that this is going to be x to the e plus 1, all divided by e plus 1. And then I can't forget my plus c, but I don't think I can really write this more simply than that. All right. We'll wrap up there for now. And we'll pick up next time and we'll do some more examples of this. But until then, be well.